Okay, ladies and gentlemen, now that we have a good idea of the criteria and everything we want to do, the next step that we're going to do is to sketch out our floor plan design. But to sketch out the floor plan, like I mentioned in the previous videos, we need to have a layout of the house and what that's going to look like. Okay, so to do that, we're going to do this on Revit. The one that I'm going to use, the lot that I mentioned earlier, that I'm going to use is lot number 19 of block 6 of the Cimarron Sky subdivision. So I need to have this information. So I'm going to use this for my site plan on Revit. Okay. So now, in using the Revit software, I'm going to go create a new project. The project template that I always want to use is the architectural template. Make sure you use that one, because if you use some of these other templates, they kind of have some weird settings on them that honestly I don't understand them. So Imperial architectural template. Imperial because it is in feet and inches. Metric is, of course, meters. Hit OK. So we're going to be building the Revit project, but for now, we're going to draw the site plan on a temporary, and I do mean temporary, B-size title block. Eventually, we are going to use a C-size title block, but the reason I want a B-size is because we're going to print it on paper so that we can do our sketching. Once we have our sketch for the site plan, we're going to come back and change it to be on a C-size title block that I'm going to provide. But for now, we're just going to be basically drawing up the property lines. We're going to draw up the using barriers and distances. But nonetheless, it is going to be on a B size on a temporary basis. We are going to still use it eventually anyway, so don't delete the file. We're still going to use it, but nonetheless, we're working on a B size title block. So for now, I'm just going to do a save as. So don't forget to save as your project. You always want to save and continue saving. And don't forget to save it to your Google Drive and your My Drive. And in this case, I'm going to use Timmy Turner. Let's see if this lets me. And then don't forget, we are in the 1317 project. So you should have all your folders created. For now, you should only have two folders, the 1317 and 1309. This, of course, is 1317. And that's what I was afraid of. So on your Google Drive, just call it Custom Home 2021 and save. Or whatever year you're working on this one. In this case, the video was created in the year 2021. All right. So as far as our site plan, we're going to go over here to the different views that we have. The level 1 is where we're going to start designing our house, but we're not going to do that yet. We are going to start on the site plan, like I mentioned. So we're going to go to this predefined view over here under floor plan that says site. So we're going to double click on site. It's going to take us to this view. Okay. So a couple of things to consider on the Revit software is these are, and I wish I knew the technical term, but even in asking architects, they can't tell me what these are. But these are the location of our elevations. So these are where you're standing to watch your elevation. So I guess we call them the elevation markers. This is your same thing. I don't know the technical term, other than it's kind of like our UCS. If we look at our, well, I guess we can call it our project base point. That's our project base point, kind of like the 0, 0 of in Revit. We're not going to do anything yet, even though we are going to come back working with this one a little later in the next week or so. We are going to adjust the angle to true north. We're not going to change that now, but just bear in mind that we are going to change the angle to rotate the north orientation so that it fits our construction documents a lot better. So nonetheless, we're going to be working with a little bit later. So this is our project base. It's kind of like the UCS 000. Okay. So I am going to base our house design. I'm going to kind of sketch out the lots somewhere like in this area right in here, where I have the project base kind of in the middle. It doesn't have to be super exact, but just roughly somewhere in there. And then the information I'm going to use is the real life information that I have. I have bearings and distances that I'm going to use on this particular lot for my subdivision. Now, remember, students, some of you guys did that on the last site plan. Do not use this lot. I need everybody to use a different lot because I want everybody to experience different information with bearings and distances. I'm just going to use this one for demonstration, but please don't use this one because I want you guys everybody to have a different lot. So unfortunately, this lot has been forbidden for anybody to use, but I do want to use it for demonstration purposes for today's video on how to draw the bearings and distances in Revit. So on Revit, going back to the site plan video view, I'm going to go over here to massing and site. And then we have this option that says property line. We're going to create the property line in Revit. We're going to click on that one. Once we do that, we have two different options on how to draw the property line. Can we enter it by bearings and distances or by sketching? Well, ladies and gentlemen, we actually have bearings and distances. So that's the option we're going to go. Enter by bearings and distances. Okay. So now we get this little chart that we can come back and edit if we have some issues with it. Not more than likely you are going to have some issues with it, so don't worry about it. I'll show you how to fix things. But first things first, we're going to need to enter the information by distance, bearing, north, south, east, west, line or arc. Radius right now is kind of ghosted out because this is a line that I'm going to start with. Um, no reason in particular, but the way I'm going to draw mine is I'm going to go from this point going this way. So I'm going to start with the northeast bearing, 324309, a distance of 133.37. And I'm going to have this bearing here heading in the southeast direction. Now, don't forget, this is once again kind of like that exercise we did already. We have to consider which way is north. And if we look at our north arrow orientation, it's pointing straight up on this document. So in this case, we do need to consider that in some cases, we do need to flip the direction depending on which way we're traveling. So the first couple of them, I can tell you right now, will stay as northeast because we had it in the northeast direction. If you consider north pointing straight up, okay? So we have north, south, east, and west. So if you notice, we are traveling in a northeast direction for that first one. So that's going to stay pretty much the way we want it. This one looks like it is traveling in a southeast direction, so we will leave that as southeast. This other one, I can tell you, is not going to be northeast. We're going to have to change that. But we'll come back to that one here in a little bit, okay? So once again, that's going to be north, south, east, and west. All right. So I'm going to start with my first one here on this document, on this Revit. So I'm just going to move it over here so I can have it for my reference. So the first one is I'm going to put in the distance of 133.37, and I'm going to type it in directly as a decimal, 133.37 feet. Okay. And then it says northeast. So this says northeast. So there's really nothing to change here. I leave that alone. Notice it changed from 133 feet. Let me make this a little bit bigger so we can see it a little bit better. And I changed it to 4 feet and 113 and 256th of an inch. But it's just because it converted my decimal of 133.37 over to feet and inches. So as long as you typed it in correctly, there's really nothing to change there. This says northeast. That's pretty much what I need it to be, northeast, 324309. You can go in here, and I've seen some students kind of highlight this one and put 32 and 4309, or you can just simply highlight the whole thing and put 32 space 43 space 09 for 32 degrees, 43 minutes, 09 seconds. Okay. And by putting the spaces, it kind of knows how to do that already. Unless you want to come in here and individually change one of these to 43 or 44, you can do that too, either one. And that's pretty much the first line. All right. The next line I'm going to type in is going to be my southeast 195. 195 is actually the whole thing. It's going to be 126.77 because I need to go from this point to this point. So I'm going to go ahead and click insert. So I'm going to insert another line. The another line distance is going to be 126.77 feet. Enter. Southeast, I'm going to go southeast, a bearing of 240920. Southeast line, very good. Okay. And I'm going to do this on purpose, and I'm going to do it wrong. I'm going to put northeast. Once again, this is wrong, but I want to show you what it's going to look like when it's wrong and how we can come back and fix it. Insert. Distance of 105.85 feet. Enter. Oops. I forgot to type that in. 105.85 feet. Enter. And then we have northeast. So I'm going to leave it northeast on purpose. Once again, it's going to be wrong. 75 space 39 space 33. Enter. Okay. This is telling us right now that it still needs to add another line to close it. So I'm going to leave that alone for now just to show you how wrong this thing looks like. And it's going to be pretty obvious. So you can kind of see This one took off in the wrong direction. And there's even a warning here. Okay. No need to panic. It's just telling us, hey, something's wrong here. This is not closed. So there's no area or nothing because this one went in the wrong direction. Okay. Once again, you can kind of see that this went in the wrong direction. So in Revit, it's pretty easy. This northeast should have been the opposite. I should have gone the opposite of northeast. I'm going to select the property line, hit edit table, and it brings us right back to the editor. So the northeast should have actually been southwest. Okay. I'm going to hit OK for now, just so you can kind of see that it's pretty easy to fix. Of course, I'm still missing some information. I'm still missing this arc here in the middle, C64. So we need to go back over here, select the line, the property line, edit table. So now let's insert to add the last one. And it's even giving us some information here. So the next thing that we need to add, it's we need to insert another piece of information. Here is giving us some information as far as the and I've never done this before. You can add a line to close. I've never done that where you just add whatever line it needs. But no, I'm going to add the information that I have from my plats, even though I don't have a line. It's actually a curve or an arc, C64. Okay, so the first things first is we need to add that other one. So I'm going to go ahead and insert. Okay. And then in this case, we are not going to add, we're not going to insert, or we inserted one, but it's not going to be a line. It's actually going to be an arc. So we're going to have a little bit more information in here. But the thing though is still asking for a distance and bearing. So what is the distance and bearing going to be if it's going to be an arc? Okay. Once again, we go back to the concept of a chord. If you may remember, the chord, let me clear this real quick. The chord is an imaginary line that goes from the beginning to the end of an arc. So that chord is the information that I need for C64 to be able to get my distance and my bearing. The radius, of course, I also get from the chart. This is the radius of C64, and then I'll explain the option that it says R and L, or L and R here in a little bit. Okay, so I need to go look for C64 over here. C64, I need to go look for my curve table. We have a tangent table also. That's for lines. The T is for tangent. It's just a fancy term for that's the lines. But if you needed to, you'd have to refer to that one. C64. So I got a bearing. Let's see, what is this? Okay, so I'm going to look at the chord bearing, and the radius are really the only three things that I need: the chord bearing, and the radius for C64. So for C64, I need to look at the chord bearing of 3660, which, by the way, that's actually pretty close to what Revit is asking for that last line. Again, we're gonna ignore this, but it's just kind of funny that it mentions that. 3660 is pretty close, and then the bearing of southeast 3548 39, 3548 40. So it's actually once again pretty close. Okay, but we're not going to use this one. It's just that's what Revit says it needs to be able to force close it if we had to. We're not. We're going to use this information here with a radius of 50 feet. Got it. So my radius is going to be 50 feet. My distance is my chord distance of 3660. And according to the chord, it says southeast. Am I headed in a southeast direction? I am not. I'm headed up in this direction, so I'm actually headed northwest. So I'm going to go opposite of southeast, northwest. And according to the plat, it says 35 degrees, so it's 35, 48, 39. Enter. Okay. Closed. Perfect. So once again, by me adding the information from the plat, it itself said closed. If it did not get this option that says closed, something went wrong. So I need to go back and start checking your bearings. Don't just add a line to close. You're faking it. You really should be working with this document here. Okay. So in my case, it's closed. And let's talk about this all R, L and R. Let me just go and put that, and I'll come back and correct it here in a little bit and hit OK. Perfect. There it is. Even though by now we know that since I started from here and it came back, there's always going to be those tiny little gaps. This is always going to happen, ladies and gentlemen. I hate to say it, but these documents, because of a precision issue, which I'll explain a little bit better next semester, there's a reason why this happens. So this is technically considered closed if it's less than 0.03 of a foot. Okay, so remember that's always going to happen, but even according to Revit, it's actually considered closed. Okay, the L and the R. Let me flip that on purpose. L, and notice what happens to this arc. So it's just putting it on the opposite side. Now what's funny is the chord doesn't change. The chord is still the imaginary line that goes from the beginning to the end. So if you think about the geometry of the chord, technically it doesn't change. So I can change that to be L and R. And nothing really happens here. And everything stays the same and still stays closed. It just puts the arc on the opposite side. Now, what does that mean? Okay, L and R, all that means is left and right. And it depends which way you're traveling. Remember, here I started from this point and I went this way and I went around and I came back this way is the way I'm traveling in a southeast southwest direction. And then this one, I'm headed in the northwest direction. So when I drew this arc, if I'm traveling here, to me, this arc is actually turning to the left. And in civil engineering terms, that's actually the way it should be from a civil engineering standpoint. Well, this is Revit. The Revit is written by architects. Architects actually see this right. So it's, if anything, I guess maybe it's on the right side of the chord, I guess. Maybe that's how you want to look at it. But to me, it's just that it's actually curving to the left. But whenever you're working with civil engineering terms, that's exactly how it is on our civil engineering software, but not to the architects. The architects see this on the right. So I guess we can just consider it to being on the right side of the chord. All righty. So that's what that means. It's either on the right or on the left. So once again, if there's anything wrong in here, we just simply just change it. Just simply change it. Oh, it's on the wrong side. Change it and call it good. Okay. Ladies and gentlemen, you need to start getting out of a habit. Something's not working. Oh my God, I'm going to start all over again. Please, ladies and gentlemen, get out of that habit. That is a horrible, disgusting habit. You should be able to go and fix the error. Maybe somewhere in here you did a southeast, northwest, or something. Okay. So just because you get something like this, oh, I'm going to start all over again because I don't know what I did. No, don't do that. That is a horrible, horrible thing to do. Right now, it's actually pretty easy because it's a small project. But when you have in real life a big, big project, you can't do that. You can't afford to start all over again. You just need to go in there and fix it. Find the error. Look at these, compare it to the plot, figure out what went wrong. Is it maybe a bearing? Is it a direction or something? Just fix it. Really, really simple. Okay. Okay. So now that we have this, ladies and gentlemen, what I want to do next is I want to put in my setbacks. But setbacks, by the way, in real life, what I would want you guys to do is go to the city of El Paso zoning map and all that stuff. I'm not going to do that now because I just want to have a demonstration. So for now, I'm just going to pretend that I have 25-foot setbacks, front and back, and 5-foot setbacks. Okay, so I'm just going to pretend you need to look up the actual zoning and the actual setbacks. To draw the setbacks, what we're going to do is we're just going to simply go to the Annotate tab and we're going to draw detail lines. And when I draw detail lines, the line styles that we have are different ones. So I'm just going to go in here and go with, I always forget which is the right one that I need to use, hidden lines. I guess I'll just go with hidden. And then from the hidden, what I'm going to do is I'm going to go ahead and draw with a setback. So when I go to place detail lines, change it over to hidden, I can go ahead and draw it with the setback already of 25 feet. And whenever I pick endpoint to endpoint, it's going to draw it already with the setback, except it's on the wrong side. So I just simply hit the space bar. There. Okay. And then my front is going to be an arc in this case. So I'm just going to go start and radius arc, start, end, and it's on the wrong side. So I'm going to hit my space bar once again. And the radius, I just simply pick the midpoint right there. Okay. Element is reversed, not a problem. Okay. I guess I didn't like that. I'll try it again. I guess I'll go with start and then radius. Oh, let me put the 25 feet. 25 feet. And my radius is right here. And then I'm going to go with my 5-foot setback. This point, wrong side, spacebar to there. Oops. Okay. Using my trim command, I'm going to use TR for trim and simply trim the lines. You notice that's a way different area of where I'm going to put my house, because now my house is going to be in this area. If I have an attached garage, this is where I need to start designing my house. I need to make sure the whole thing fits. If I have a detached garage, like I said, we do need to put that outside. So we probably should at this point. And if you don't, that's not a big deal. Just consider where the easements are at, okay? Because once again, we'd hate to put a detached garage if there was an easement on the back. Because remember, easements are anywhere. They could be anywhere. So just be careful of that. Okay. So then the last thing I want to do is I want to go and create a sheet. So over here on the bottom, and I'm done with the site plan for now. Again, this is really the only thing I need. Is I'm going to go to my sheets, right click, I'm going to create a new sheet. I'm going to load temporarily, I'm going to load a title block. I'm going to go with a B-size title block. That way I can print on the B-size printer that we have here in the classroom. If you don't have you can put it temporarily on an A-size if you want to print it from home, whatever the case may be. So I'm just going to use the B-size title block and hit open. There it is. Load it. Okay. And then to drop the site plan in here, I'm just going to go back and make sure that it's, right now I'm on sheet A101. I'm in this view. I'm going to press and hold, drag and drop, press and hold with the mouse, the site plan onto my sheet. And there it is. Okay. This is at a 1 inch equals 20 feet. That is a civil engineering scale. You could use that scale if you want to. This is actually the area that's more critical. So I can actually go with a bigger scale if I wanted to. It'll probably be a little bit easier. Maybe at 3/32. Remember, for now, this is the only part that's critical to me. So I can maybe use that one. Or if I wanted to go something a little bit bigger, maybe a 1 inch equals 10 feet. Or that's, of course, a civil engineering scale. I can go back to an architectural scale, 1/8 of an inch equals a foot. That could probably work too. Remember, this is the part that's critical. So as long as we're able to print something out on paper and sketch on it, it's whatever scale you want to use. 3/32 or whatever scale we want to use, okay? So then once we have this, what I'm going to do is I'm going to go print it. So it depends which printer you're using here in the classroom. At this point here in 2021, the big printer is actually the B-size printer is the CP5225, and that one is offline, so I need to go and restart it. But nonetheless, that is going to be the B-size printer, so it prints an 11/17. Okay. If you decided to use a A-size title block, this is a B-size title block. If you wanted to go with an A-size title block, I'd have to go and load it. Then you have to go print it to the appropriate printer. But for now, here in the classroom, it is going to be um, on the B-size title block. The only other thing we have to do is we have to go to setup, change the actual paper size. In our case, it's going to be 11/17 for B size, letter for A size. We also need to change the fit to page. We need to change that over to zoom to be 100%, because if we don't do that, ladies and gentlemen, it is not going to be to the right scale. So we have to go to zoom 100%, center it, hit OK, and preview it. Notice it fits the sheet nicely. Okay. You can tell when it's wrong when it's, if I go to preview and I forgot to, oops, let's say I forgot to set it to the right scale. If I hit fit to page, again, I forgot to do that, and I preview it. If you see these little gaps, ladies and gentlemen, this right in here, something's wrong. We should not have that. This is actually the edge of the paper. So the edge of the paper is actually showing up here. So if you're seeing this little gap right in there, something's wrong. Stop. You might be sketching it, but it will not be the scale. Okay, so make sure that you are zooming 100%. This is very, very important. So you need to make sure to go to setup, change the right paper size, zoom 100%. Once you have that, you preview it. I forgot to center it. Sorry. Yeah, sometimes I hit escape by accident. Go to setup. Make sure you zoom 100%, center, get the right paper size, preview. Once again, you'll see how it's right up to the edge. Print it, and the rest will be doing face to face because I need to show you how to work with a scale. Start scaling and sketching, ladies and gentlemen. Thank you very much.